you have only one force, right? The gravitational force, mg. So the only force, mg is m. So the work done by the net force is simply the work done by the gravitational force. You have only one force, right? So here you would get K minus K naught equals to Wg for the special case. Any question here? K minus K naught equals to Wg. Now, let's use the definition of these quantities. K is 1/2 mv squared. Okay. K naught is 1/2 mv naught squared. And the work done by the gravitational force should be the force multiplied by distance multiplied by cosine theta. The force is mg. The distance, what is the traveling distance in this case? It's the delta y here, right? And multiplied by cosine theta. What is the theta here? 0 degree, so cosine theta equals to 1. Okay, so the equation is simply this. Cosine theta equals to 1. Now, okay, I don't know if you have this question. It seems that I have to calculate this term, I have to know the mass, but I didn't give you the mass. What's wrong here? Okay, it cancels out. And then we get 1/2 v squared minus 1/2 v naught squared equals to g multiplied by delta y. V naught equals to 0, right? So this term goes to 0. So you get 1/2 v squared equals to g multiplied by delta y. V squared equals to 2g delta y, and v equals to square root of 2g delta y. And you can check that this will give you the same answer here. Okay. In fact, the two equations looks very like with each other, right? So this is the calculation using the work kinetic energy theorem. Okay? Now, I'm trying to use the conservation of mechanical energy. First, can you see that this is a conservative system? You have only one conservative force, you don't even have non-conservative force, so WNC must be 0, right? So this has to be a conservative system. So you can use the mechanical energy conservation. The mechanical energy conservation, it says that the change in the mechanical energy equals to 0, or you can write it as E equals to E naught equals to E, or K naught plus U naught equals to K plus U. Okay. So the summation of the initial kinetic energy and the initial potential energy should be the same as the summation of final kinetic energy and final potential energy. So we're going to use this equation to do the calculation. Okay. So K naught plus U naught equals to K plus U. Okay. So 1/2 mv naught squared plus mg y naught equals to 1/2 mv squared plus mg y. Right? That's the equation. Now we know v naught, we know v, but we have to specify the initial height and final height, y naught and y. To do that, you need to choose your zero reference point. In this case, you can choose here as your zero reference point, right? So if you do this choice, what is y naught and what is y?
Y naught is 490.
Okay, yes, y naught meter, what is y? Final height?
0.
0. Okay? So y equals to 0, y naught equals to 490. Now let's check. We have this equation. If y equals to 0, so mgy, this term, will go to 0. Right? Will go to 0. And we also know the initial velocity v naught equals to 0. So 1/2 mv naught squared. This term goes to 0. Right? Okay. Then we get mg y naught equals to 1/2 mv squared. Again, here mass can be cancelled. Okay. So you get g y naught equals to 1/2 v squared, or v squared equals to 2g y naught equals to square root of 2 times 9.8 times 490 equals to 98 meter per second. Okay. So this is a very simple example, but I would like you to go through the 3 different methods of calculation. Okay. With such simple example, it can help you to understand the procedure, these 3 different methods clearly. Okay, what you are going to do with each term here. Okay, how do you set up these equations? Okay, and so here, if you try to do the problem, the best way I would think is mechanical energy conservation. Okay, because once you establish the equation, the calculation contains less tricky points. And for these things, you always have some tricky points. For example, for this one, it has cosine theta here, and sometimes you may have the trouble to identify the theta, angle theta. And here, it contains a problem of the positive and negative side. You have to choose the positive direction and assign some appropriate side. Okay, sometimes people may make mistake by doing that. So, and this one is more linear.